Hello, and thank you for joining us for part 2 of our presentation, the easy way to achieve near zero downtime for SAP. My name is Harry Ausler, and I'm the EMEA Pre-Sales Director for SIOS Technology. For those of you who are not familiar with SIOS, we specialize in delivering high availability and disaster recovery solutions to ensure uptime for key mission-critical applications and databases such as SAP and SQL Server. Our wide range of solutions allow us to help companies with their availability SLAs regardless of platform, operating system, application, or database. In part 1, we explored how some of the key parts of an SAP architecture can be vulnerable to outages. We discussed some of the challenges companies face today in achieving their availability SLAs across their IT infrastructure and highlighted some of the common configurations customers deploy to ensure operational resiliency for SAP. Part 2 of our presentation continues the discussion around achieving SAP SLAs and introduces SIOS technology and our capabilities for protecting SAP. We'll emphasize the importance of SAP uptime and discuss how we can measure availability to help us define those critical SLAs for SAP. We'll then introduce the technologies SIOS deliver through our portfolio of high availability clustering solutions and provide some examples of how our customers are leveraging and benefiting from our solutions today. For those of you who are new to SIOS, we were founded back in 1999, and over the past 20 years, we've been an industry leader in delivering solutions for high availability and disaster recovery. We are headquartered in San Mateo in California. However, we have a global presence with additional offices in the US and also in the UK, Singapore, and Japan. We are recognized experts in application availability with more than 80,000 licenses installed worldwide across a wide range of industry sectors. However, a large part of our success comes down to the technology alliance partnerships that we hold with many vendors, as you can see on the screen there. Additionally, we also have a world-class technical support team who are able to offer our customers a 24/7 follow-the-sun support model. In the previous presentation, we discussed how the emergence of virtualized computing and now cloud computing has offered key benefits for reducing cost and improving IT agility and flexibility. We'd discussed how companies are moving away from traditional data centers made up of physical servers to what we refer to as the new data center, which is a combination of physical, virtual, and cloud environments. We also identified that the new data center gives IT the flexibility to deploy and configure their applications in a way that best meets their business needs. Despite these benefits, some companies prefer to keep their critical applications on physical servers only. This is where they can run them in well-defined environments. This being said, as physical servers begin to age, their interest is growing rapidly in moving towards the inclusion of cloud environments as well, where they can gain some of the significant advantages offered by the new data center. However, these migrations or IT modernization initiatives or digital transformations can create new challenges in maintaining established application SLAs in the new data center. When we're speaking about the inclusion of cloud platforms in the new data center, we are specifically focusing our attention around mission-critical applications. When we're speaking of mission-critical applications, we're talking towards applications such as SAP. As we know, SAP is at the heart of many organizations, providing that centralized management capability into their day-to-day business operations. Through its wide range of applications, it provides key functionality such as enhancing productivity, providing better inventory management, endorsing quality, effective HR management, reducing expenses, and enhancing profits. However, companies need to be a little careful in how this centralized architecture is deployed and managed. We've all heard the term, never put all your eggs in one basket. That term applies to all sorts of things, and in this case we're referring to data and mission critical systems. As mentioned earlier, we're directing this message specifically towards SAP. In today's world, many businesses rely heavily on SAP systems for day-to-day business operations. However, this centralized way of operating is risky. If one or many of the core central SAP components were to become unavailable, this could lead to unplanned downtime, which could impact the business in many different ways. Downtime, as we all know, is costly and disruptive. An interesting quote released by our friends at Gartner recently states, the average cost of an IT outage is $5,600 per minute, and as much as $540,000 per hour at the higher end. When we're talking about this level of disruptiveness, the finger of blame could get pointed at those who are responsible for managing the infrastructure and related applications. Application downtime will be noticed by groups of users or potentially the whole business. The last thing you would want as a systems administrator is that phone call from the CEO or the MD asking why the sales dashboards are not available, or that phone call at 3 a.m. with a user complaining that they can't access their data. If we can preempt those calls and handle any downtime before anyone has noticed, this not only helps a system administrator manage the infrastructure more efficiently and reliably, but it also makes them look like a bit of a rock star. What we're trying to say here is that high availability and disaster protection is essential. I'm sure we're all familiar with service level agreements. It's that commitment between a service provider and a client to ensure that aspects such as quality, availability, and responsibilities are agreed between and by all parties. From a SIOS standpoint, we're specifically focusing on how to help companies with their availability SLAs, particularly for mission-critical applications like SAP. Meeting availability SLAs requires measuring availability using two key metrics. Firstly, we use a metric referred to as the recovery time objective. This defines the amount of time it takes to detect a failure, recover from that failure, and then continue running. Clearly, the shorter the RTO, the more likely you can meet your SLA. In parallel to this, we also have to consider a second metric, which we call the recovery point objective. The RPO is pointed towards data availability, and more specifically, how up-to-date our data needs to be in the event of a failure. For non-critical systems, your data set that you are recovering to could be up to an hour or even a day behind your production data set. However, for more critical systems, RPOs may need to be defined in terms of minutes or even seconds. Again, the shorter the RPO, the more likely you will meet your SLAs. To help companies meet some of those recovery time and recovery point objectives, here at SIOS, we focus on delivering a range of solutions that are based around the concepts of high availability clustering. We're all familiar with what a traditional cluster looks like. It's generally made up of a number of redundant server nodes, which allow us to fail over and fail back whatever application it is that we're protecting. The application itself, in most cases, tends to be cluster aware, whether this is something like SAP or even databases like SQL Server and Oracle. From a storage standpoint, we're usually relying upon some sort of shared storage model, and in most cases, this is a SAN. However, this is where we begin to see a few issues. Firstly, deploying, configuring, and managing a SAN can be expensive. And also, from an availability standpoint, a SAN or whatever shared storage model you may be using is actually a single point of failure. If for whatever reason we lost our SAN, we pretty much lose our whole cluster. Another issue is this shared storage model is not suitable for cloud deployments. So all of a sudden we now have an obstacle that gets in the way of achieving our new data center objectives. The challenge is therefore to take this high availability architecture and rebuild it in a way where we can eliminate any single points of failure whilst also at the same time make it more suitable for cloud deployments and thus address some of those new data center objectives. So to address some of those challenges, here at SIOS we've developed what we call a Sandless clustering model. And as the name suggests, this is a clustering architecture that does not rely upon any form of shared storage. Instead, we're utilizing the storage that's available to us within each of our cluster nodes. So, if this were a physical cluster, we could be relying upon internal storage or direct attached storage. In a cluster that may be sitting in the cloud, we're just utilizing cloud storage that's attached to each node. However, because we're now not using shared storage and we have two separate sets of storage, we have to introduce a replication engine between the cluster nodes. This allows us to synchronize the data between node A and node B. The replication engine that SIOS delivers can be based on either a synchronous replication model or an asynchronous replication model, depending upon the recovery point objectives you need to achieve. The replication engine itself is based upon a reliable and efficient block-based replication engine. It's in fact the same replication engine we've been using for the last 20 years. So this is a proven piece of technology. In this particular scenario, we're protecting some of the functions for SAP. On node 1, we are running our central instances, and we're also running our databases. And these are active, noted by the green color. On node 2, we also have a database in our central instance, but as you'll notice, these are in standby mode. So these functions are not actually running on this server at this time. However, we are running other functions on node 2. In this case, we're running the application server. So we're utilizing both nodes at the same time to improve efficiency across our cluster. Now, in the scenario of node 1 failing, this will initiate a failover of those active services over to node 2. And we'll slowly see these services moving over from node to node. And this process is very straightforward and handled within our technology stack. And as you can see, our services have fully failed over. Node 1 is completely down, and we're now running all of our active SAP functions on node 2. If in the event node 1 comes back and is repaired, we can reverse the replication and resynchronize the data sets so we can add any new data that was added whilst we're in a failover state. And then we can also reverse the failover and run a failback where we can take those particular SAP functions and fail them back to the original node. Now, very interestingly, this scenario can be deployed regardless of whether you're running on physical cluster nodes within your data center, whether you're thinking about moving your application into the cloud and want to run a cluster within either a public cloud or a private cloud, or whether you're considering a hybrid scenario where node 1 could be sitting on premise on a physical server and node 2 could actually be a cloud instance. The configuration and the process is also certified by many of our key partners. This technology is certified by SAP, both for integration with SAP NetWeaver and for SAP HANA. But we also get a good level of qualification from our other technology partners as well, particularly the cloud vendors like AWS, Microsoft Azure, and Google Cloud. Now, in the previous example, we were using a model where we were running our SAP functions and our database on the same cluster nodes. Whilst this is a feasible configuration and one which would be supported by SIOS, it's not typically something we see in the real world. One of the downsides of running your SAP functions and your database on the same nodes is that we're potentially restricting resource allocations on those particular components, and thus that could be impacting the performance of our cluster. What we see many customers do is actually separate out two clusters to manage their application and their databases. So here in this example, we have an application cluster which is specifically managing our SAP functions like ASCS, CSC, PAS, and ERS. We then have a separate database cluster which is sitting underneath, and that database could be whatever you want. It could be HANA, DB2, MaxDB, but the point is it's a separate cluster. What this allows us is it allows us to ensure performance is not restricted by any resource allocation constraints. Now, in a cloud deployment, we see many customers taking these separate clusters and deploying them in a single availability zone. As we know, an availability zone is the equivalent of a data center. But if we're putting our entire cluster in one availability zone, that could potentially be a single point of failure. And availability zones have known to have gone down. Now, to be able to address this and eliminate that single point of failure, one of the recommendations from a SIOS perspective is to split our cluster nodes across availability zones. So that gives us the ability to not have to rely upon one AZ and eliminate that single point of failure. Some customers take their level of resiliency even further, and they want to introduce a third node into their cluster, but want to build this more for disaster recovery and to be able to manage regional disasters. So they end up hosting that third node either within a third availability zone or within another region. The point here is whatever flexibility you want to build around your resiliency, SIOS will be able to build the appropriate availability model for you. Let's start looking at some of the solutions that can help us achieve some of these availability SLAs that we've been speaking about. And from an SAP standpoint, the primary solution that we position is the SIOS Protection Suite for Linux. Now, the reason why we describe this as a suite is because we bring together three core pieces that work together to deliver availability for SAP. Firstly, we have this component called Lifekeeper. Very importantly, Lifekeeper is our high availability clustering technology for Linux platforms. This is the piece that can monitor all of the components, all of the functions, all of the services that are running within your SAP stack and your entire server stack, and make sure that those pieces are available at any given time. If it sees a fault, if it sees an error, if it sees the need to fail over, it can either fail over individual services or, if necessary, fail over a complete cluster node. In terms of the failover, we can manage that either automatically or at a push of a button. In parallel to that, we also run this piece which we call Data Keeper. Very simply, Data Keeper is our host-based block level replication engine. This is the piece that enables clustering without having to rely upon shared storage. So this is the piece that synchronizes our data between node to node and allows us to synchronize either asynchronously or synchronously, again depending upon the recovery point objectives that you're looking for. And lastly, we have what we call the Application Recovery Kits, or sometimes we refer to these as ARCs. And these ARCs, for want of a better term, I feel are really the magic sauce behind the whole solution. This is where a lot of the application level intelligence resides in terms of how we protect specific applications and how we fail them over and how we fail them back. These are essentially out-of-the-box wizard-based setups that allow you not only to automate the configuration of your protection and your failover, but also manage that failover and failback if the need arises. So for example, we have a wide range of these kits based on various applications like SAP, for example. We've got kits based for various databases such as HANA, Oracle, DB2. The list is endless. We'll come back to the application recovery kits a bit later and do a slightly deeper dive on what the kit looks like specifically for SAP. So let's take these three pieces and depict where exactly within the server stack they sit and the elements that they're protecting. So here's a very simple illustration of a two-node cluster. On the left we have node 1 or host 1 sitting in availability zone A, and on the right we've got host B sitting in availability zone B. So taking those three pieces I've just spoken about, let's start at the bottom. I spoke about those application recovery kits. So the pieces of the stack that they're protecting are things like your application, so in this case SAP, any other services within the stack that are require protection, things like your IP layers, things like NFS. Data keeper, as we mentioned, is our data replication aspect. So that's the piece that's sitting at the data layer. And the piece that umbrellas the whole environment, as we spoke about earlier, is Lifekeeper. This is the piece that's monitoring all of these different pieces and it's orchestrating your failover and failback when required. So what we have here at an overall level is this ability to deliver application level awareness and whole cluster level awareness in terms of what's going on within your cluster at any given time. Let's take a deeper dive into some of those application recovery kits. As I mentioned earlier, this is where a lot of our intelligence resides within the whole solution. If you recall, the application recovery kits are predefined scripts that we supply as part of our solution to help you automate the protection for various components in your environment. So as you can see here, we have a range of application recovery kits that can help us protect different components. We can protect various Linux components such as Apache, Samba, NFS, and so on. We have particular recovery kits for particular applications like SAP and WebSphere, and we'll talk more about the SAP recovery kit in a moment. We also have recovery kits designed for specific databases. So if you're running Oracle, MySQL, Sybase, DB2, or even SAP HANA, we've got the necessary kits that help us automate the protection, the failover, the failback of those components. And for customers who are running physical servers and maybe running physical storage arrays, again, we have a range of recovery kits that allow us to integrate with those technologies. This is by no means the whole list of our recovery kits. This is purely the tip of the iceberg. And certainly as we work with you to develop your protection for your critical applications, we will identify which of our kits will be the most suitable for you to use. In part one of our presentation, we spoke a little bit about what a typical SAP architecture looks like and identified some of the single points of failure within that architecture. These unprotected pieces include the central services, the on-queue service, and any underlying databases, which are all critical for the smooth running of SAP. If any of these pieces were to become unavailable through either an application, a server instance, or infrastructure outage, this can warrant the whole SAP system to become unavailable and cause disruption to the entire business operation. So going back to some of those arcs that we mentioned earlier, here's an illustration depicting which arc SIOS can supply as part of our SAP protection solution and where exactly these arcs fit in terms of the SAP landscape. As you can see, we can deliver specific arcs for key parts of the architecture, such as the SAP Arc, which allows us to protect functions such as ASCS, ERS, and much more. We'll talk more about the SAP Arc in the next slide. We can deliver arcs for specific databases, including HANA, MaxDB, or DB2, or we can protect functions such as NFS if necessary. The HANA Arc in this case allows us to deliver an automated failover and failback feature between HANA nodes to avoid having to take any manual failover efforts. While SIOS clusters the HANA nodes, HANA system replication will continue to synchronize the data between nodes. The SAP Application Recovery Kit is really the core part of our solution where the SAP intelligence resides. This is the piece which is SAP aware to deliver high availability to ensure maximum uptime. What it does, it verifies that SAP is running, it ensures that any file shares or NFS exports are available, and it also ensures that databases are mounted and available. So what it will do, it will drill down and it will monitor key functions within the SAP environment and provide protection for those components. So the kind of components we're talking about are the primary application server, ASCS function, CSC, your on-queue and message servers, and your on-queue replication server. Very importantly, the SIOS protection suite for Linux in combination with the SAP Recovery Kit is intelligent to understand that in an S/4HANA environment, it should not be running the ASCS function and the ERS function on the same nodes. The best practice from SAP for these functions is to run them on separate nodes. And that's certainly something we can do with SIOS. However, if you need to fail over one of those services, let's say for example the node which was running our ASCS function fails and we need to fail over to another node. Initially the SIOS solution will try and fail over to a node where ERS is not running because we want to maintain SAP best practice. However, in a real life scenario, you might find yourself in a position where the only available node to fail over to is where ERS is already running. So the SAP Application Recovery Kit does have the intelligence to override SAP best practice and make sure that the ASCS function can fail over to a node where ERS is already running. That way we maintain maximum uptime for both those critical functions. Now in parallel to the SAP Recovery Kit, we also have those database recovery kits I spoke about earlier, where we can protect various databases such as Oracle, HANA, MaxDB, and much more. But the SAP Application Recovery Kit also ensures that our shared and or replicated file systems are available, our logical volumes are available, our NFS mounts and exports are available, and all of our virtual IPs are set. SIOS are by no means the only vendor who address availability considerations for SAP. Some of the Linux distributions also offer some entry-level features for high availability. However, given the criticality of SAP for most companies, one has to understand if these OS-based features are delivering the SLAs set by the business. Let's talk about some of these core features that the SIOS solution can provide. Firstly, we can deliver comprehensive OS-agnostic, high-availability Linux protection. This means we can use our solution regardless of what the underlying Linux distribution is, whether it's SUSE, Red Hat, Oracle Linux, or even CentOS. We can deliver infrastructure-level high availability with monitoring of the entire application environment. This includes monitoring your servers, storage, operating system, network, database, and of course the application itself. We spoke earlier about those application recovery kits, which can provide advanced application integration and orchestrated failover of all key ERP and database systems, including SAP NetWeaver, SAP S/4HANA, and including databases such as Oracle, MaxDB, HANA, DB2, PostgreSQL, and many, many more. We also have that ability to deploy multi-node geo-redundant clustering models, where we can create 3 or more node clusters with nodes in geographically separated locations, availability zones, or even cloud regions for disaster recovery protection. We also deliver that complete configuration flexibility, the ability to create clusters in any combination of physical, virtual, and cloud without any rigid site-specific rules. Very importantly, from an ease of use perspective, we have that wizard-driven configuration ability through our application recovery kits, where no configuration files, manual scripting, or complex network settings have to be done at a manual level. Fully automated site failover, including automatic network routing if you're running your cluster either within AWS or within Microsoft Azure. And lastly, there's no specialized application knowledge needed. And what we're doing here is we're reducing the risk of any potential errors that might be caused by any manual tasks or manual scripting. Within the previous presentation, we spoke about the various architectures that can be deployed today that can be used to meet various SLAs. Here at SIOS, we are the availability experts, particularly when it comes to protecting mission-critical applications like SAP. Working with SIOS ensures that we can build an SAP infrastructure that is easy to manage and support, able to deliver enterprise-level reliability and availability. We can design configurations that are able to meet serviceability needs, such as patching or backups, without impacting the availability of the SAP application. Very importantly, we also deliver our availability capabilities in a cost-effective way, ensuring we maintain maximum performance of the SAP application is also very important, whilst at the same time efficiently utilizing the infrastructure resources. Now, it's easy for me to speak about the value SIOS can bring if you're looking to deliver high availability for SAP. But as equally as important is also to provide you with some examples of customers who are doing this today. These are customers who are using SIOS technology to meet those strict availability SLAs they have on SAP. And as you can see, we have customers from a wide variety of industry sectors. Wherever there is an availability need, SIOS can help. Some of these deployments are based on small 2 to 3 node SAP configurations. Others are much larger, with some customers protecting up to 30 plus SAP systems with SIOS. Some customers are using our technology on-premise. Others have taken the step to deploy SAP into the public cloud platforms such as Azure and AWS, where they find that the availability features of the native cloud platforms don't quite meet their availability SLAs, and thus rely upon SIOS for SAP protection in the cloud. Most of our SAP deployments are based on Linux across a wide variety of databases, but we also have some customers who deploy the ASCS function of the SAP architecture on a Windows Server failover cluster, where we have additional solutions that allow them to run a Windows Server failover cluster in a Sandless fashion, either on-premise or on the cloud. In essence, we have an availability solution no matter what the platform is, whether it's physical servers, virtualized servers, or cloud instances. Whatever the operating system is, whether it's a Linux distribution or whether you want to run on Windows, and regardless of what the application is or what the underlying database is. So, if there's anything I would like you to take away from this session, it's really some of these key points about SIOS. SIOS are able to deliver high availability clusters in physical, virtual, or cloud environments, and we deliver solutions that are qualified by both AWS and Azure and thoroughly tested to protect your applications against outages in those environments. SIOS integrates with SAP to deliver overall availability protection through automation of setup, monitoring, and failure management within SAP environments. Our SIOS Lifekeeper solution has built-in tools to ensure SAP best practices are followed to deliver maximum availability. SIOS can deliver a recovery point objective of 0 on your data and a recovery time objective of a matter of seconds, meeting or exceeding any on-premise SLAs that you might have today. And lastly, SIOS delivers greater value and more flexibility for a fraction of your overall tech stack cost. Thank you for taking the time to listen to our presentation. I hope you have found these sessions useful. If you would like to get further information about our solutions, please do reach out to me on either email, LinkedIn, or Twitter, or via the SIOS website. Thank you.